Okay, here is mass of electron, which is 9.0938356 into 10 power minus 31, and then here also proton, we have neutron, and if we see the mass of proton and neutron, it's almost the same. Here is 1.6726 and here is 1.6749, and here the exponential power is same here, minus 24, minus 24. And if we compare minus 31 and minus 24, which is bigger, we know that the smaller negative value is always bigger in the power of this negative. So we know that here also the proton is of mass is a little bit bigger than this neutron. So he explained that inside the nucleus mostly is made out of proton, and so it's every atom consists of a tiny central particle, which is nucleus, and it's made out of mass, and with their mass is means this the mass of proton and neutron, and it's made out of most of mass, and whenever the particle is striking the nucleus, it will have a large scattering angle because the particles are positive charge, and this one also positive charge, so they will have a large scattering angle, and he explained. And then he also found out that the radius of the nucleus, let's say the radius is 10 power minus 15 meter, and that of radius of atom is minus 10 power minus 10 only. And here atom is bigger and nucleus is very way smaller than atom. And then he said that electrons are not stationary. It means they are not stable, but it is revolving around the nucleus. Therefore, this nucleus is electrically neutral. And then whenever these electrons are revolving around the nucleus, and inside is, we know that there's proton, or we can say positive charge, and the attraction between this positive charge and this the negative charge, it provides that the centripetal force, which means it will go inside to these electrons are revolving like this, like this, like this. And whenever they are still revolving around, it will not fall into the center. And he explained that because of these electrons are revolving around the nucleus, the proton charge, and this attraction force between these two charges keep the stable for their orbit. And then he cannot explain the stability of the nucleus. And now we are going to discuss about the drawback of Rutherford's atomic model. Okay, now this is a drawback of Rutherford atomic model. It means drawback means he failed to explain, and he cannot explain the stability of the nucleus. And now we talk about the nucleus here, and then here is electron, and about when this electron is revolved and how it will stable and how they will keep their stability. He could not explain this point. And then one is the light spectrum. There is nucleus, and when he do the experiment, they know that the rays are coming, and there is emission of the rays and something like that. They observe by seeing the light or some kind of colors, and they are called the light spectrum. When the lights are forming, he cannot explain the formation of those lights or the colors. And then number three is number three is that according to this Maxwell's theory, Maxwell he said that whenever the two opposite charges, one is positive and negative, they are revolving each other, they will lose. It means this will go here or this will come here. They must lose, or they must radiate the energy. Whenever these two they revolve each other, they must radiate energy according to Maxwell theory. Therefore, he failed to explain the stability of nucleus. And after Rutherford, Neil Bohr is going to explain all these things. And in the next topic, we are going to talk about Neil Bohr's atomic model.